What's going on YouTube? My name is Joel Rivera, and it's time to learn something new. In the last video we expanded our original network by adding an additional site. After adding that site, we created a virtual tunnel interface between both locations using a GRE tunnel. And once we created that GRE tunnel, we used a dynamic routing protocol, which was EIGRP. You may recall that at the end of that video, I had said that although we were successful to connect these two sites using the GRE tunnel, technically we weren't secure. And the reason we're not secure is because we're not using any encryption over that tunnel interface. So all that traffic between both locations, if we're just using GRE, is just clear text. Now, using a GRE tunnel is great because we get the capabilities of using broadcast traffic, unicast traffic, and multicast traffic. And the fact that we have multicast traffic is what allows us to use that dynamic routing protocol between both locations. But, as I said, it's clear text, so it's not protected. So the way we get our data to be protected is that we need to use IPSEC. So in today's video, we're going to be doing a lab where we do a GRE over IPSEC. And that way we can have the capabilities that GRE provides, which allows us to use our dynamic routing protocols, but have it protected over the IPSEC protocols. Now, IPSEC is a framework that uses multiple technologies in order to provide that encryption. The IPSEC process is actually divided up into two different phases, Ike Phase 1 and Ike Phase 2. Ike stands for Internet Key Exchange. Now, before I get into the configuration of our two peers, which are Router 1 and Router 2, I like to go over the 5 steps that I use in order to remember what I need to do to create that IPSEC tunnel. These are the 5 steps that I use in order to remember what I need to do for the IPSEC tunnel. So in the Cisco world, we define our interesting traffic using ACLs. So in this lab, what we're going to do is we're going to create an access control list and have it permit our GRE traffic, because anything that goes over that physical interface is going to be writing that GRE tunnel, right? And that's what we actually want to encrypt. So in our configurations, we'll be creating an ACL, and I'm going to be using ACL 100, and I need to permit that GRE traffic, and we're going to make sure it's sorry, let me write that again, and we're going to permit that GRE traffic and make sure it's any. So basically any traffic that goes from one side to the other over that GRE tunnel is going to be protected using the IPSEC tunnel. So the second step that I go through when I'm creating the configuration is remembering that Ike Phase 1 equals ISACAMP. Now, ISACAMP stands for Internet Security Association Key Management Protocol. So in Ike Phase 1, the ISACAMP protocol is divided up into 2 different steps. The first is the security association step, and then the second is the key management protocol. And I try to remember it that way so that when I'm going through the process of entering the configs, I know which step to go first. I try to remember it using the anagram head. First is our hashing parameter, then our encryption, then the authentication that we're going to use, and then our last is the Diffie-Hellman group. So the hashing algorithm that we're going to use in our lab is SHA-256. The encryption that we're going to be using is AES-256. And then the authentication, we're going to be using a pre-shared key. And for Diffie-Hellman group, we're going to be using group 5. The important thing for Diffie-Hellman, the Diffie-Hellman group determines the strength of the key. So the higher the group is the higher bit rate, which provides the strength of the key during the key exchange. And the second part of the IPSEC configuration is the key management protocol portion of it, and that's where we will be setting up the, we'll be adding the configuration for the key itself. Okay. After we finish complete the Ike Phase 1, we go into the Ike Phase 2 portion of the IPSEC configuration. So for the third step of the IPSEC configurations that we'll be doing is Ike Phase 2. I always try to remember this part is where you do the IPSEC transform set. And this is where we're going to set our encapsulation security payload. So ESP is the key word there. Transform set and ESP, encapsulating security payload. So encapsulating security payload is what is used to secure the actual full payload. So and this part is during the transform set. We're gonna set the ESP encryption to use ESP AES, and it's going to be AES-256. And then for our hashing, we're going to be using ESP-SHA-256 HMAC. And the key thing to also remember in this portion, we're going to define the mode that we're going to be using, and the mode we're going to be using is tunnel mode. All right, and then after that third step, we'll be doing the crypto map portion. The crypto map is where we're going to tie everything together. So with the crypto map, we're going to set our peer, not set peep, set our peer. And the next thing we're going to do in the crypto map configuration is indicate our transform set which we will define in step 3. And we also need to, in our crypto map, is set the access list that we're going to use, which earlier I said the access list that we're going to use is 100. So we'll match the address of ACL 100 for that part. So in the fourth step, we created the crypto map. And then in the fifth step, we're actually going to tie it to that physical interface. And the physical interface that we're going to use is our outbound interface, which is Ethernet 0.1 for both of our peers or both of our routers. All right, so again, these are the 5 steps that I like to try to remember. And I wrote it down now, and I'm going to review it as we go through it. So the first thing I'm going to need to do is I didn't set up my lab. I only turned on my routers. But let me make sure I start all my nodes. I already have my routers ready to go, so we can already start that process. But might as well turn on all the devices in this lab. So let's start off first with router 1. Let me go back to this page and bring up here router 1. All right, so the first thing I said is we're going to define the ACL, or define our interesting traffic. Now, interesting traffic is everything that you want, is the traffic that you want to secure. So in our lab scenario, we want to secure the traffic that goes through that GRE tunnel. Now let's step into this. So obviously we need to go into the global config mode, and in our global config, if we're going to create an access list, we're going to type access list 100. We're going to permit, because we need that traffic to be permitted, and we're going to permit our GRE traffic, and from any to any, using that GRE traffic, we want that to be protected. So we're creating the access list as such. Now our second part of our configuration is the ISACAMP portion. So we're going to type crypto ISACAMP. We're going to set the policy first. So it's crypto ISACAMP policy, and then the priority number, which I'm just going to use 10. The priority number, if you have multiple policies, so if you were to create multiple policies, multiple ISACAMP policies, you can set the priority, and the lower number will be done first before the higher number, right? So I'm just using the number 10 because when I was learning to do this, that was the policy number that they use. The policy number is not too important unless you have multiple crypto ISACAMP policies on your router. So crypto ISACAMP policy 10, and like I said, this is where we do the security association. The security association are your parameters that the Ike Phase 1 needs in order to create that tunnel. So as I was saying, you can use, I remember using head. So when I do the crypto ISACAMP policy, I start first with our hash. And our hash, we're going to do SHA. Yeah, SHA-256. And then we're going to set our encryption. So our encryption is going to be, I said we were going to use AES. So encryption AES 256. Then we're going to go into the authentication. So our authentication that we use, we're going to be doing a pre-shared key. A pre-shared key is just a password for both sides. You can use RSA signatures and another certificates if you don't want to use pre-shared keys. But in our lab environment, pre-shared key is going to be suffice for us. So we're going to use authentication dash pre-share. And now for the Diffie-Hellman group, we just type group, and I'm going to use group 5, but I just wanted to do the question mark so you can see the different group values. So the higher the group value, the higher the bit rate and the strength of the key that is going to be used during that key exchange. So we're just, in our lab environment, going to use group 5, and that should be suffice. Okay, and then the last thing to remember in the ISACAMP portion is we want to set a lifetime. So I'm going to create the lifetime, which is going to be in seconds. So I'm going to use 3600, which is which is an hour for our tunnel to stay up. Now we get into the key management portion of the ISACAMP. So we just type exit to get out of the security association parameters that we were doing, and we jump into the to the key portion. So for the key, we're going to do crypto ISACAMP, and this is where we do our key. And the key that we're going to use is we're going to just create a secret password. So I'm going to use secret pass as our key. and we're going to type our peer address that we're going to be communicating with. So for router 1, its peer is router 2, and the address that we're going to use is the publicly accessible IP, which in our lab environment is the 172.129. Sorry, 172.29.129.61 for router 2, and router 1 is 129.129. So now we've completed the ISACAMP portion, and I'm gonna take a step back real quick and start to configure the same to catch up router 2's configuration. So again, I'm gonna enable first, then go into global config mode. First thing we're gonna do is create that ACL. So the ACL is just typing access list. Using the extended access list, so we're going to use access list 100, and then we're going to type GRE because that's our traffic that we want to be protected through the IPsec tunnel, and we're going to make sure it's any to any, so that both ways that traffic gets permitted. And I miswrote access list. So access list 100 permit GRE any, right? So that's the first portion of it. Now we go back to the Ike Phase 1, which is the ISACAMP portion. And we're going to type crypto ISACAMP policy. And we're going to use the same policy. And this is where we're going to do the security association. So again, head, so hashing. So hash SHA-256. Now the configuration's got to be the same on router 2 as it is on router 1. The only difference will be obviously is the peer address in our when we do the key portion is going to be different, but the configurations for your ISACAMP security associations are going to be the same, and obviously the password, which is the authentication pre-shared key, is going to be the same. So next part is encryption, and we're going to use AES 256. Authentication is that pre-shared key. And last is the group, the Diffie-Hellman group, so group 5. And we're going to set the same lifetime of 3600. All right. Now we exit out of the security association portion of the ISACAMP and jump into to type the key management portion, which is crypto ISACAMP key. And this is where we're going to type the same password, so secret pass. You obviously use a different password, not a simple password that's easy to figure out. I'm just using secret pass because we're in a lab environment. But in your work environment, wherever you do this in real life, you wouldn't be using a simple password like that. Secret pass is our password, and then we're going to type the peer address, so address. And for router 2, it's 172.29.129.129, which is router 1's Ethernet 01's physical IP address. Okay. So now we've completed the Ike Phase 1 on both router 1 and router 2. So let's go back to router 1, and you can use this page. So router 1. Now for the Ike Phase 2, again, I always try to remember for Ike Phase 2 is the IPsec transform set. So we're going to do crypto IPsec transform set. And we're going to name the transform set. I'm just going to do trans set that we're going to be using. So I'm sorry, we're going to be using encapsulating security payload AES, and for our HMAC, for our hashing, we're going to use SHA-256-HMAC. So ESP-AES, and we're using AES 256. So space 256, and then we're going to type ESP-SHA-256-HMAC. All right. And again, as I explained earlier, this is where we're going to set the mode. So in order to set the mode, we can either use transport or tunnel. In this lab, we're going to use tunnel. So now that we've completed that, let me do the same on router 2 first. Router 2, again, crypto, IPSEC, transform set, I'm going to trans-set, and then we're going to use ESP-AES, so encapsulating security payload with the authentication of AES is advanced encryption standard with the bit rate of 256, and we're also going to use the encapsulating security payload SHA-256 hashing algorithm with HMAC, which is our hash-based message authentication code. And as I did earlier, I'm going to set the mode to tunnel. Okay, so now we've completed Ike Phase 1 portion, the ISACAMP portion on router 1 and router 2, and we also completed the Ike Phase 2 portion on router 1 and router 2. Now we're going to set into, we're going to do our fourth step, which is the crypto map step. And in crypto map, this is where we're going to create our map. So we type crypto map, and then using the mapping tag, we're going to call it my map. And the sequence number, we're going to use 10. And we want to use IPSEC with ISACAMP. So when you complete this portion, you'll get that message where it indicates this crypto map will remain disabled until a peer and valid access lists have been configured. So basically, it's telling you that warning, like once you set this, it will remain disabled until we have a valid peer. Okay. So we're going to do that on both router 1 and router 2. And as I explained, for the crypto map, we're going to first set our peer. So set peer. And we're going to use the peer address. So for router 1, I'm on router 1. We're going to put the router 2's outbound interface, which is Ethernet 01's IP address. So 172.29.129.61. And then we're going to set the transform set. So set transform set. And we have to type the same tag that we used earlier. So set transform set trans set. And then the last portion is to match our ACL. So we use ACL 100. So it's match address 100. All right. So we're going to complete the same configuration on router 2. But again, router 2, we're going to use router 1's peer address. So set peer 172.29.129.129, which is router 1's outbound interface IP. And then we're going to set the transform set. So set transform dash set. And we're going to use the same tag as was written when we created the Ike Phase 2 transform set. So trans dash set. And last, we're going to match the ACL, so match address 100. And that's it. Now the last step, which is setting on our physical interface, so for both router 1 and router 2, it's Ethernet 01, our outbound interface. So we're going to type interface Ethernet 0/1 and type crypto map my map. So it's going to indicate to use the crypto map that we created. So I wanted to show you something here. So first thing we're going to notice is that ISACamp was turned on this router, but you'll notice that we have dropped our ERGRP peer neighbor. The reason why is because currently we have the configuration completely set on router 1, but its peer, router 2, is not. So all we have to do again is, log into that physical interface. So Ethernet 0/1 and set the crypto map that we just created. So crypto map my map. And we should turn on ISACamp on router 2 with that. And you'll see that our tunnel 12, which was the GRE tunnel that we had, is up. And we have a new adjacency. So router 1 and router 2 are now seeing each other over that IPsec tunnel, which is our encrypted channel, right? So we're done at this step. I'm just going to save the configuration on both routers. But we are done now. So now our data that is passing through from router 1 to router 2 will be protected. So any data that's going through that tunnel will be protected using that IPsec tunnel. So one thing you want to do is see the security association for Ike Phase 1 and Ike Phase 2. So for Ike Phase 1 is ISACamp. So show crypto ISACamp SA. And that's going to show you that it's currently active. Obviously, for router 1, this destination is its peer, which is router 2's IP, and the source being its outbound interface on router 1. And to see the Ike Phase 2 configurations, we're going to do show crypto IPsec SA. And you'll see with this show command that we're using the crypto map tag my map. Its local address is the 172.29.129.129, but its remote peer is the 129.61. We're using, so you can see here, current peer. And what else that we configured? So we use encapsulated security payload AES, and I'm trying to find that here. AES. Yeah, here it is. The transform set that we're using, which is our encapsulated security payload AES 256 and SHA-256, which is our hashing algorithm. Remember, hashing provides data integrity. So we use hashing in order to verify that the data is accurate. So you take if you take any type of data and you pass it through the hashing algorithm, you will get a hashing key, and once you transfer that data on the other side, if the router, the second router, does a check on that data, which it will do through the IPsec configuration, it'll verify the hashing of that data, and it should match on both sides, right? So that's how it verifies the accuracy of your data. All right. So yeah, that's about it for this lab. Um, pretty easy at the same time, pretty complicated. It's multi steps. So when you're going through it, take your time. If you remember these 5 steps and you break it down how I did, and you do this over and over again, it'll get easier. That's just how I've done it since I learned how to do IPsec tunnels, and it just works for me. So again, you define your interesting traffic, which is obviously any traffic going through that GRE tunnel. We want that to be protected. So that's our interesting traffic. In Ike Phase 1 is synonymous with ISACAMP. So the configuration that we did on our Cisco routers, you know, when we type crypto ISA camp, that is the Ike Phase 1 portion of the configuration. So crypto ISA camp, the security association portion is where we enter the security parameters. And at that portion, like I said, I use head to remember. So hashing, encryption, authentication, and Diffie-Hellman group. I use that to remember what I need to enter. So first you put in the hashing algorithm, SHA-256, then the encryption algorithm, which is AES, Advanced Encryption Standard 256, and then the authentication mode that we're going to use, which is the pre-shared key, and the Diffie-Hellman group, which we use group 5. All that needs to be the same on your both of your peers when you're doing this type of configuration. If not, then you're not going to get your IPsec tunnels up and running, right? The Ike Phase 2 portion of the configuration is where you do the transform set. So I always remember crypto IPsec transform set, and that's the Ike Phase 2 portion, and that's where you type your encapsulated security payload information. So ESP dash AES, which is the encryption standard that we're using with 256 bit rate, and then ESP SHA-256 dash HMAC, which is our hashing algorithm that the IPsec configuration is using. And then after you do those steps, you'll jump into the crypto map portion, which is what ties everything together, and that's where you set your peer. You set the transform set that you previously used in Ike Phase 2, and you match the address of the ACL that we created. So that's just how I remember how to do it. And then last but not least, you enter the physical interface of that outbound interface, and that's where you set the crypto map configuration. So that's where you type crypto map, and then that's where you type crypto map, and the map, the the map tag, which in our lab we use my map. All right. So that's about it for this lab. I'm still debating if I should continue using this lab and expand on it. I may or may not. I think I may just start doing smaller labs, and create a brand new lab scenario. I think we've done enough with uh, this original topology. So it might be time to create a brand new topology and start going through labs. But anyways, if you want more videos like this, don't forget to like this video and obviously subscribe to see more videos like this. And comment down below on your experience through the lab, and what you think about this video, and so on and so forth. Until next time, bye.